Hello, everybody, and welcome to the visualization of neural network. This, net- this network demonstrates the optical character recognition problem and tries to understand a particular handwritten digit and classify it based on which digit it belongs to from 0 to 9. The visualization helps to look inside the inner working of a neural network by animating the changes each neuron goes through as the network learns and trains to understand the handwritten characters. Let's take a tour. We can control the configuration of the network by inputting values from these boxes. If I want to configure a network that trains on one sample each of each digit, 6 layers having 6 neurons each, one alpha value and a threshold value, and I click on create and our network is created. Each of the layers are color coded, which means the first layer is the red neurons, which belong to a single layer, then the pink, and so forth. This here is our output layer, which has 10 neurons, which belongs to each to each classes. So this is 0, 1, 2, and 9. When you hover over these neurons, you can see some yellow highlights. This indicates the that each of these neurons here is actually a whole image, and these yellow values are all the same. So you can see this is minus 8.02, and so for this is also minus 8.02. Hence, for the first layer, the input is a complete image, all the 6 cross 6, that means 36 pixels, which act as an input to each neuron of the first layer. You will see later that these will map to the image as seen by the computer. When you click on each neuron, you can see that it is connected to individual to which neurons it is individually connected. So all the connections are displayed, and hence one can track down these connections individually. One can also separate them to see what individual connections are happening as they happen during our visualization. I can control the speed of the visualization by using the slider, the leftmost being the fast and the rightmost being the slow. I'll move it towards slow side. Now, when I click on train, you can see that the network has started training. You can see the changes inside each neuron, where each neuron grows in size or reduces in size depending upon the values increasing or decreasing. This is the input image that is fed, which is the pre-processed image, uh, uh, and this is the image that after processing is fed to the system. If you click or hover here, you can see that there is a mapping on the image as seen by the computer, which indicates the pixels that are input to each of the nodes. Once the network is training, the, there are no digits recognized, and hence it shows that the network is learning. So there's a handy tooltip to read meanwhile as the network trains while on the values. You can also read the individual values by clicking and hovering over each of the values. If there is no change in the values, the color does not change. Once the network has been trained, it displays done, and then it is ready for the next phase, which is the testing phase. Now, when we click on testing the network, you can see that some of the values are being displayed here, which is the value that has the highest classification in these neurons. You can see that a 1 is being recognized as 7, which is completely incorrect, while 2 is being recognized as 2. the reason for the inaccuracy is because the network is not very robust here in this case. You can see that it is trained just on one sample, and then there are just six layers and six neurons each. We know about the neural networks that as the more number of samples, the more accurate the network is. So there are around 10,000 samples available, 1,000 samples of each network, and so you can actually increase this value to around 1,000, and hence it will be a better and more robust network. For that, you will have to increase the speed, and you would not be able to see the visualization as it in detail when you increase the speed of um, the visualization. That's it. That's it for now. Thank you so much.